Hello, everybody. It's Holger Mueller here from Constellation Research, here to talk to you about one of the most exciting things in technology right now, which is quantum technology. I'm here with one of the experts, Heather Higgins, partner at IBM in the quantum technology field. Thank you, Heather, for coming. Thanks for joining.
My pleasure. Looking forward to the discussion.
One of the most interesting questions that we have in quantum is which use cases will be available and can be tackled. Can you give us some details about what you think will be coming around the corner?
Sure. I'll just start for those that aren't necessarily familiar with the field of quantum computing. It's not just a faster, better version of classical compute. And so the target applications that we focus on are those that are very computationally complex, where classical compute is unreasonably difficult or intractable based on either the sheer size, the complexity, or the inability to follow a specific predictability path.
Very interesting, right? And there's limitations which you can't get in compute, so it makes it ideal for quantum. What is a good example for use case that you're planning to tackle?
Sure. So I think the market's converging around three different broad application areas: simulating nature, advanced mathematics, and complex data structures, along with search and optimization. So those are really broad categories. And within those categories, there's many use cases, making it really hard to answer questions at a use case level, or even an aggregate level around the business value and timelines. So we look at patterns which are emerging across various types of problems and really try to contextualize those based on typical problem size, complexity, and even ability to predict. Good really does vary by enterprise client. What's good for one client's not necessarily good for another. They vary based on not just the quantum potential, but really alignment against unique organizational priorities, their risk appetite, and each organization's timeline to value thresholds. Within IBM, I'd say within the three broad categories, we've got about a dozen use cases that we monitor for enterprise investment. And so that's how I would really categorize the way that we look at, good use cases in those 12 span from near term to, more longer term opportunities that are disruptive.
Very interesting. Good to see that such a heterogeneous uptake from that example. But can you give us some tangible examples of what is really happening?
Sure. Let's take each of the categories. I'll start with advanced mathematics and complex data structures. That's where you would have your AI and quantum machine learning patterns that exist. And so within that category, I would say we're really looking at things like classification and clustering, which show promise for near-term business utility. So examples would be customer experience analytics, anomaly or other fraud detection type use cases that would span a breadth of industries from banking, insurance, healthcare, life sciences, and manufacturing based. If we switch over to optimization as another broad category, I'd point to combinatorial problems that would unlock utility across mobility use cases, including, say, electrical vehicle routing within the auto industry. You could even look at grid optimization within the energy and utility space. And then the third category is simulating nature. And so within there, I'd say some of the more disruptive problem categories would include vibrational or electronic structures, which really speak to a lot of what you hear about in terms of focus and investment around battery design and catalysis.
Very interesting. Great to see this broad spectrum where quantum can be applied. What do you think will be the first use cases which would unlock quantum utility and business value?
Yes, I got to dust off the crystal ball here. It's the million-dollar question, and one that's fairly elusive and will probably change.
Only $1 million, Heather? I thought it would say it's a couple billion dollars at least.
Well, probably it is a couple billion. I would agree with that, Holger. So what's the first use case to quantum utility, business value, commercialization? I'll hedge my bet a little bit because there's a lot of variables to consider, not only our IBM development and innovation roadmaps, but advances in the overall technology landscape where you have, various individual technologies continuing to push and leapfrog in terms of their capabilities. From my own perspective, informed by our own roadmap updates and experience working with enterprises and on an increasing basis on large-scale prototypes, I would be optimistic that classification problems are showing very near-term promise as one example. These are problems that have a lot of symbiotic opportunities for quantum machine learning to contribute alongside AI in these workflows. These classification problems also render themselves very well to hybrid solution architecture, so we can extract enough quantum information using near-term quantum circuits instead of resorting to the longer-term fault-tolerant approaches. And then I'd finally say another reason for this class of problems being interesting to me is that we're learning a lot about how to encode various types of data sets by industry and how to apply different error mitigation techniques and focus on how we can abstract the complexity for, say, enterprise data scientists through new Qiskit patterns.
Very interesting. The classification part has a lot of promise. Very good to see that. Another way of looking at this is not just to looking what could be the use cases, but what is available from the capacity from a qubit perspective. Right? What's your point of view if you just look at the available qubits, like in the rest of the year, the next year, and so on?
Yeah, so qubit count's important, and it has been, since the beginning of time. I'd say that within the current industry, that often becomes the sole area of focus as a primary indicator of progress. And so while it's important, I would say it's not sufficient to represent the degree of utility that quantum systems offer today. So when you think about enterprises and others that are assessing the potential of near-term use cases, you really need to step back and look holistically at performance, including not only scalability, but also the quality and speed metrics. And one of the things that, we introduced with the new roadmap is a really holistic, view on scale, quality, and speed.
Very interesting, and glad that you talk about the roadmap. Enterprises want to see roadmaps because they can plan their rollouts and adoption of technology. You've significantly expanded your roadmap coming here at Summit. What is the reason that you expanded it, and why it's important for the near-term use cases?
Yeah, so we've been publishing a roadmap, as you know, for quite some time, and hitting those, metrics pretty consistently. I think as we've been, doing this for some time, and we were getting closer and closer to, where the roadmap was timing out, it required us to really step back and take an expanded step. The other thing I would say is that 2023 has been a pivotal year, a year where we've shifted from an era of discovery to an era of utility. And so for the enterprise, our roadmap reflects a few things. One, an optimal balance point between scale, quality, and speed. So we're leaning into focus on error mitigation runtime, which is necessary to unlock business utility and business value much earlier than what we had previously expected. The second thing that you'll see in the roadmap is acceleration in error correction techniques, which is really important because that enables a faster path to modularity and to quantum-centric supercomputing. And then the third is, really recognition that quantum's hard. Building the skills of an algorithm developer is a steep hill to climb. And so we're really looking at broader accessibility of quantum systems and quantum problems, recognizing that pervasive skills will continue to be a constraint, and looking at how we can abstract and simplify some of the techniques.
Very interesting. Lots of insightful stuff, Heather. But you said something which is like typical for quantum right now. It is very hard, right? So let's look at the other side of the spending, right? We said the revenue coming in on the other side, but spending from enterprise on the other side. What and when and how should enterprises prepare for quantum technology?
Yeah, so, regardless of where an enterprise is, I'd say the time to start is now. I think you'll hear a lot of folks in the industry, echoing that same and reinforcing that same point. I would say that how an organization chooses to invest and to prepare themselves for quantum will vary. It'll vary based on their risk-reward appetite. It'll vary based on organizational dynamics. So the time is now. The approach that they want to take in terms of, monitoring and engaging with quantum will 100% vary. You have examples of pioneering organizations that are really starting to invest heavily. They want to be first to market with a portfolio of use case applications and a time-bounded integration map. And on the other side, there's a lot of organizations that are content to wait until they have frictionless tools that will enable integration of quantum solutions without having to so heavily invest up front in the specialized fields of algorithm algorithm development and error correction. So I'd say, both approaches are valid. They'll coexist actually in the same organization, I think, in the foreseeable future. So my advice is to some of the C-level decision makers is to start preparing now, but be really purposeful on which investment approach they want to take. I guess I would close by saying that the technology is fundamentally different than today's compute. It's advancing at a rate that is much faster than even many of us in the industry had expected. And so I think that we're at the point now where, we're at the inflection point where we can do things, that are not possible with classical compute. We're pulling in both timelines faster. And so the time right now is to start to monitoring, to develop your strategy, be purposeful about what it is that you're trying to get out. Fast followers, not a terrible thing, but start now and do what, right size it for your organization, what your needs are, because it's gonna happen. It's gonna happen sooner than we think. And I think that, what you don't want to have is to be surprised by the industry standing up around yourselves.
Yeah. No, that's great advice. And I think the key thing is what you said is we see an acceleration that nobody could have expected or would have expected. And that's the time where CXOs and enterprises have to pay attention and look at technology, which might be solving very key problems for them. I want to thank you, Heather. This was super insightful, a lot great of advice for anybody listening here. Thank you very much for being here. Appreciate it.
My pleasure. Thank you.